EMBA735 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this clip we will see how to use the Vensim software to create causal loop diagrams and to copy such diagrams over to a Word document if you were to want to incorporate it into an assignment or a report that you're creating. So you may recall that a causal loop diagram consists of variables and causal links. So this is the Vensim screen that you see when you start up the software. If you don't see exactly the screen with the buttons that I'm pointing to at the moment, then just click on New Model, and then from the Model Settings dialog box that shows up, just click OK, and you should get the screen that you see before you now. So the button, the tool that we would use to create a variable. So we'll create a very simple causal loop diagram, one that reflects how the cruise control in your car works. So one of the variables that's involved in the operation of a cruise control is your desired speed. So you can see I picked up the button called variable. Notice I didn't pick the button which says box variable. Okay, so I pick up the button which says variable and I drop it into my screen anywhere, and I write the name of the variable, desired speed, and I hit enter. So there's one of my variables in the causal loop diagram. The second variable, of course, is your current speed. So there's my second variable. I hit enter again. Okay, and the third variable in this picture is your throttle, how much gas you give. That's basically what it is. So there's my third variable. Okay, so now notice that I pick up this tool which has the hand in it, and I can use that to move the variables around in my picture anywhere to make it look nice. So I'll set my desired speed at one position in the diagram, and here's my current speed. And of course the difference between the desired and current speeds, I'm introducing another variable, speed difference. Okay, so I got 4 variables here. So the greater the difference between my desired speed and the current speed, the more I'm going to use the throttle to try and make up for the difference. So now that I have these variables in the picture, I'm going to try and set up the causal links over here. So notice that I'm picking up the tool which says arrow, which is my causal link. So I will create a link from throttle to current speed. So notice that the way I do that is by touching the cause variable first and then moving my cursor over to the effect variable next. And I have to touch the variable actually, and that creates the causal link. And you see this little circle over here, this is a handle that you can use to shape the arrow any way you want. To make it curved or straight, and you can use it to make things look nice. Okay, so here is a causal link from throttle to current speed. So throttle is the cause, current speed is the effect. Everything else remaining constant. If I move up the throttle, if I increase the throttle, the current speed should go up. So this is a positive link. So to set the polarity on the link, I will just right click on the link, and this little dialog box shows up, and you can see all these little choices over here. So I pick a positive polarity for the link, and you can choose to put the polarity in the middle of the link and so forth. You can try out these options on your own, but the main option here is the polarity of the link. So I click OK, and you can see that I have a positive causal link from throttle to current speed, meaning if throttle goes up, the current speed goes up. Okay, all right, now the other link that you can see should exist is a link from speed difference to throttle. Notice how I drew the link. I first touch the cause and then I touch the effect, and that created the causal link from speed difference to throttle. And what I'm trying to reflect with this causal link is that the greater the speed difference, meaning the greater the difference between my desired speed and the current speed, the more I want to increase the throttle. So this is a positive link as well. So I right click on the link and I put a positive polarity on the link. Okay. All right. So now all that remains is, what is the link from desired speed to speed difference? Okay. Other things remaining constant, if my desired speed is higher, then the difference between the desired speed and my current speed will be higher. So here is, I'll touch the cause first, the desired speed, then I touch speed difference, the effect second. I'm going to curve this arrow a little bit. So remember, just a repetition, I touch the handle over here, I hold my left button down, and then I can move the arrow around as I wish. Okay. So now everything else remaining constant, if the desired speed goes up, the difference will also go up. What's the difference? The difference is the difference between the desired speed and the current speed. So again, I will right click on this arrow, on this causal link, and I'll put a positive link on it. Okay. The last link that I'm going to draw is the link from current speed to speed difference. Again, I started at the cause and I ended at the effect. So I touch speed difference and I'll bend this arrow a little bit just to make the circles look nice. So the way to do that is I touch the handle of the arrow, then I hold my left button down on the mouse, and then I drag the arrow over to make it look a little more nice in the picture. Okay, now how about the polarity? Everything else remaining constant, if the current speed goes up, then the difference between the current speed and the desired speed goes down. So this is a negative link. So I right click my arrow and I put a negative link on it. Okay, so there I have a causal loop diagram. You can save this file by giving it a name. So file, save as, and then you can give whatever name you wish to this particular causal loop diagram. I'm not going to save it right now. Okay, so you can look at this picture and I have a causal loop. So if I follow the arrows over here from current speed to speed difference to throttle back to current speed, you have a feedback loop. And if you follow the polarities minus, plus, plus, this is a negative feedback loop. That's exactly what a cruise control does. When you set a desired speed on a cruise control, then the throttle in your car automatically acts, either it increases or decreases, auto throttles, until your current speed increases to match the desired speed. Okay. Okay, so this is the purpose of this clip was not to explain causal loop diagrams to you, but rather to show you how to use the software to draw the causal loop diagram. Now, if you want to move this picture around on your screen, so you can see I held the left button down on my mouse and I highlighted the entire picture, and now I can move the whole picture around anywhere on the screen. So just to make it visually more appealing, you can do that. Now if I wanted to capture this entire causal loop diagram and copy it over to a Word document, let's say you are preparing a homework assignment or a report and you wanted to insert this picture into your Word document, then all you would do is, again, remember I'm using this button which says move and size. I just hold my left button down and I highlight the entire diagram. Okay. And then I click on copy, and here is an empty Word document that I had set up already for this purpose, and I right click in the Word document and I paste. Okay, and the causal loop diagram gets pasted to your Word document. You can resize the causal loop diagram to fit fit the appearances of your Word document and so forth. So this is a very simple use of the tool. Remember, I think I mentioned in an earlier or a different video clip that this Vensim software is a full-fledged simulation software, but we are not using it for simulation. We're using it simply as a drawing tool because we want to keep our discussions managerial, and we're not going to do any mathematical modeling. Okay, another button that you may find helpful is if you do make mistakes. So we all make mistakes. So let's say I misspelled throttle and I want to change it to throttles. Okay, so since throttle is a variable, I would just click on the variable button, touch throttle, and change it. Okay, so you can change the name if you like. Now, if you want to delete things from this picture, then you would pick up the delete button that from the toolbox, that toolbar that you see over here, and click on whatever variable or link you want to delete. So let's say I want to delete the link between speed difference with throttle. I would just touch the link. Be sure to touch the link and not the variable. So I touch the link and the link goes away. Okay. All right. Now, suppose I want to delete the variable current speed. I will touch current speed with this delete icon and it will remove. But also notice some side effect. If I remove a variable, then any links attached to that variable also get deleted. So here I'm about to delete current speed. So here I go, I delete current speed. Not only does the variable disappear, but all links connected to it disappear. So this is really the extent of the use of this software for drawing purposes that we are going to employ in this course. Okay, so we will have enough opportunity to use this software again, but I wanted to have a separate video clip just on the use of this Vensim software for drawing causal loop diagrams.